Alrighty. Looks like we're live to me. I just was doing a little bit of exposure tuning on my Sony mirrorless camera here, and I think that the lighting is a little less like uh, overexposed. I guess the video of me is a little less overexposed, which I think should be helpful, so it's not quite as much of a kind of like pop of white color. Um, I also think I was more zoomed in yesterday. I'm not sure how much better that is. That seems a little better. Um, Probably don't want to be zoomed in too much on my face, but yeah, I think this looks better. The video quality still looks kind of low to me, um, and so I'm gonna need to check on addressing that. Let me see here. Yeah, I've got it up. So I'm watching the stream back of myself here, and it looks like the quality is pretty low. Although it also doesn't say anything about. It says my connection is excellent. So yeah, I guess we'll keep going with this. If folks feel like the quality is just horrible, then we can obviously adjust. Anyway, let's go ahead and get back into what we're going to work on today. So yesterday we were kind of like reviving a UART the UART sending side of our on Moss. Oh, actually, I just was able to restore um, all of what we had yesterday. Let me transition over to, yeah, there we go. All right, so this is what we looked at yesterday. I was actually going to post this on Twitter. Maybe I'll do it today. But so I had previously had the transmission side or the sending side of the FPGA or of the UART on the FPGA implemented. And we did a little bit of tuning to that to make it send exactly what we wanted. We had some issues with like the least significant bit and that sort of thing. And so also I'm going to hop back over in case if anyone jumps in the chat. Also, I am getting a warning on the video resolution here. I'm going to see if I can switch the resolution live. Let's see if that makes it upset. Video bitrate. $51,000 kbps. Let's see. Current resolution. Says it recommends using a bitrate of 1,000. So let's try lowering our bitrate. See if that helps at all. Okay, so our bitrate should change, but the resolution is what we also want to update here. Oh, wait, the change off out. Let's see. Let's actually look up best resolution for YouTube streaming. Yeah, okay, so 1920 by 1080 is likely what we'd want here. So it says I have to turn off the streaming to be able to adjust this. So I'm going to do that temporarily here. Hopefully, well, let me see if it'll end the stream. I don't want to end the stream. I think I can just stop going live here for a second. So I will be right back. All right, let's see if that's any better. I'm still getting some warnings here. The resolution is 1920 by 1080, which is not ideal. Let's see. Let's see. It does seem to be unhappy about my updates here. Stream settings, stream health. What is the optimal resolution you want here? Okay, so it says it's loading, but I think it might actually be working based on what I'm seeing. If I try to take a look at this on my other machine. Well, now it's saying no data, so I'm not 100% sure here. All right, we're gonna go for it. And if anyone is in the chat right now, let me know if you're able to hear things, see things, etc., etc. And we'll see how that works out. Okay, so it does look like it's streaming. It says excellent connection. I think there's just a weird loading thing on my side. Okay, and it actually is giving me some positive messages here. Okay, I do need to do one other thing, and that is fix up my camera here with video capture device. Okay, and I want the cam link. Let's see here. Okay. And where is it? Input 1. Main. Video capture device. Let's actually just see here if when I transition over, if it works okay here. Okay, so it is working, but it's unfortunately not showing my face on here. And I'm going to monitor the stream on my other machine here and see how that works. So we'll grab this and I can cut back over. So it hasn't been the most exhilarating stream thus far, but I think this is part of the deal here. I'm going to make sure I don't get any feedback here and go over to channel, live, and make sure this is working okay here. It does look like it's good on this end. So, well, the quality doesn't look great, but it is coming through. So that's at least positive. Yeah, it's not horrible. It's not great either. Okay, let me try one more thing to get my camera up and going here, and then we will be all good. Oh, hold on. I think I see it. Let me stop streaming. All right, and we should be good now. I can transition over and everything is looking pretty good. Let me check the quality coming through over here. It does look like we have one viewer. Thanks for sticking around. We are gonna actually get started now. Let me pull this up, and yeah, quality is pretty low. Let me know how it's coming through on your end if you're in the chat. All right, so back to what we are actually doing today. We are going to work on the receiver side. So yesterday we were able to run the ARTI A7, we were able to put our UART sender essentially on there, and it looks something like, let's see if I have this up. We want to go to moscomp/mos. All right. So in our RTL here, we fixed our UART transmission. And so essentially what we're doing is just sending this string over and over again, or once, and then have like a reset and that sort of thing. So it can send, and that's great. But we want to be able to also receive. And what I'd like to do today is actually get to echoing back, right? So if we send a message from my host machine where the dev board is plugged into, I'd like to be able to echo that back to the host machine. And then what we're going to do after that is start actually sending like instructions and things like that. We do have a very, very nascent ALU implementation, so we can start to wire that up. But really what we're doing is kind of like the first part of connecting two Verilog modules together, because prior, right, we just had this one, and it was invoked, if you will, by top here, right? So we're passing in the RxD out here, which we talked a little bit about why this is the receiver, even though we're sending on it. This diagram kind of gives us a little indication of that. So anyway, let's go ahead and get started. So I've done a little bit of work on this already. And I was just leaving a note here about why the output was defined as a register here. Also, let me make this a little bigger. I think I had it one bigger yesterday. And we'll shrink this down quite a bit. Okay, so the outputs are declared as a register, which is, I posted this on Twitter last night as well, is essentially the same. Now that I'm monitoring the stream, it wants to open things on my other Chrome window, which is off screen. I'll pull this up over here. So essentially saying output register foo is the same thing as, by default, all ports, which are inputs, outputs, or in out. And we'll definitely get the Verilog notes up here soon. But here I noted this down. Output ports, or I guess all ports, are wire by default. And so all ports are wire by default. We're assigning it as a register, which is the same as is helpfully explained in the Stack Overflow comment, as just saying output wire, declaring another register, and then on every invocation saying, or every like execution, every clock cycle, saying that we want to assign it to whatever the register is, right? So we have something that holds state and something that doesn't. And so instead, when we say output reg foo, then, or output reg foo, I don't know what everyone's preferred situation is there, but when we're saying output register foo, we're basically using shorthand for doing that stateful assignment to a stateless variable. The terminology in Verilog can get very confusing. I'm going to try, as we build this out, to talk in the same vernacular. And we do have some terms documentation in here. And so let's see if I can find the terms. FPGA serial tools. Terms. Here we go. So I am trying to be consistent. Once again, all this stuff still needs to be pushed up for folks to be able to consume, but I want to get it in a decent condition before then. Yeah, I'm going to try to be consistent, but Verilog is very underspecified. One of the things that I've kind of complained about, try not to complain too much, but is Verilog, when you look up kind of like information on how something works, a lot of it is like, well, invoke your compiler, invoke your toolchain, and see what happens, which is not the most helpful feedback in my opinion. But anyway, yeah, we're gonna go with it. So the sender has been modified here. And so instead of having that hard-coded string, which is literally like put into the FPGA, we have this data where we're saying, hey, send this data. And then a wire that's saying send, like do the action. So really, and once again, right, we're all learning as we go here. But really what kind of the model that I have in my head here is, let's take, we'll make this receiver UART RX. These are our modules, our two Verilog modules here. Let me zoom in here so that it looks nicer on the stream. And then we have UART TX. So we'll pop this over. And then all of this is in, we'll say top.v. All right, let's make this actually, what are we calling these? UART RX.v. We'll use the actual names here. UART TX.v. Okay, so really what we want to say is that coming in, we're going to have, we have our sending and receiving up here, right? The board is giving us that in the definition files here. So let's fill these in. Oops. Okay, so we have these. And what we want to do is say, we have some wires here, right? So things that are connecting these two modules. What is that? How many is that? 4, 5, 6, 7, 8. I think that's right. 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. So these are our data wires here. Let's see. And then we also have our send wire, which is basically like, hey, do the thing. I feel like that using this like sloppy font, even though I love it from Excalidraw, is maybe making things a little harder than they need to be. Let's see if we can clean up some of this, make them not sloppy. Other than now I'll be held responsible for things actually looking nice. That's kind of like I guess an inside joke you might say at Upbound, where all the developers love using Excalidraw because it gets us off the hook from actually producing designs that look good, which is actually like a reasonable thing, right? Spending too much time on that would not be a great use of our time. So I think it's actually a good tenet that we have, but I know some of our design folks don't love it. Don't love Excalidraw as a product. They're fine with us using it as developers. All right. So we have our wires here. So this looks pretty good. And this would essentially be, let's say, so this is our, technically going back up and looking at our stuff here, where our RX is the TX for the FTDI chip. And so our receiver is actually on, this is going to be a little confusing. Our receiver is taking the UART TXD in, So let's go ahead and label that UART TXT in, and what is it? UART. I guess that it's actually not really mislabeled. So I think I was maybe a little presumptuous about that the other day because it is saying in, right? And then we're sending on receiver out. So actually it makes sense. I still think it's confusing though. And I did receive some validation from some other folks that were like, oh yeah, I struggled with that. So maybe not the only one, who knows? Okay, so we want to say that we're going to come in and read off of here. Let's say. And then a similar thing where we're coming up here. So basically what we want to do is read from here until we can fill up the data buffer, if you will. And then go and, so like these are set. That's where we're doing like the output register situation, right? So we're saying, hey, this is a register, which is essentially a wire that is going to be driven by a stateful element. And then on the sender side, we now have that coming in as input. So once again, these signals are set. And then we're saying, hey, don't actually act on these until send is in, whatever state we're looking for there. And so if we go down, we previously had so send before. Okay, send before was like flipping the switch. If y'all remember yesterday, we'd flip the switch and start sending. And now instead we're saying, hey, send whenever that wire is driven high, which we're going to do for just one cycle down here. Yeah, tell TX to send. And then the cleanup here, I don't think we actually need to be doing anything. Also, I want to note this is heavily inspired by, there's somewhere here, this NAND Gates website has a Verilog UART NAND Gate. I took a peek at this, NAND Land. So they have an example, which is very similar to ours, for VHDL and Verilog. Let's see. And they even have test benches and stuff like that. It's not exactly the same, but it is similar in that, like they have signals and inputs and outputs and whatever, and their states declared. Yeah, we have a few different things. There's a couple places where I feel like they're using too many registers or more than they need to. And so, for instance, they're saying, this is actually a good example. So they're saying, yep, this is really a wire. And so since it's a wire, we need to assign it to, so what did we say? ORX byte. Yeah. Okay, so ORX byte is the actual wire. So if we're looking at our picture here, it's data. And they're saying that, so yeah, that's the data that they'd be sending out to whatever's receiving it. And then if we go into here, they have our RX byte. So I think this is saying like output and register. So actually probably a good naming convention there. Maybe we'll clean that up. But it has this byte, and it's saying that we actually write to the RX byte here. Let's see if we can find. Yeah, okay, so in data bits it should be. So we're setting whatever data we're reading. off the serial connection. So, right, we have like one wire coming in and we're essentially sampling it. So coming in, saying on, this interval, this number of clock cycles, whatever the baud rate is, we are going to sample it. And then, at each sampling period, we're going to drive one of these wires here. So we want that wire to stay the same. So if we go sequentially, first this is 1, let's say at the first sampling, we want to drive this first one to 1. And then we want to be able to say, stay at 1, right? Maintain state. And when we're maintaining state, that's when we need a stateful element like a register. So what they're doing to accomplish that is using a register, RxByte here, and they're setting the value. But then on every time through, right, every execution, every clock cycle, I need to work on that terminology, but every clock cycle here, they are actually going to just assign the wire to the stateful element. So first, when we do that first sampling of a data bit and it's 1, then in the stateful element we have 1, and on all of those clock cycles, it's just saying essentially over and over again. And I'm kind of trying to relate this to a software realm, but over and over again, it's saying that we want to drive, the 0 index wire to 1, or we're doing least significant bit, so the 7th index, I guess, here. Okay, so, but what we're trying to do is something similar, but once we get all of the data, we want to say, send that back. And I feel like some of the timing might get a little crazy here. So we're going to have to stick with me through that. Let's see. So I want to finish this comment. The outputs below are declared as registers, which is essentially shorthand for instantiating a register and assigning the wire to it on every clock cycle. Okay. So we're actually saying when send, what is send here? Send is the output. And we're saying when it's low, we want to send, so we're saying when it's high. No, sorry. Yeah, when it's low, we want to trigger sending. I don't actually know the custom for this. Should idle be low or high on wire? I guess I guess it doesn't matter, but this looks like it could be a good resource here. High level abstraction. Yeah, this looks useful. I'm going to add this to our resources over in Verilog. It's not really useful for what I'm trying to answer right now. I don't think what I'm trying to answer actually matters. Let's see, what was this called? Verilog overview. And Verilog overview. All right. We really should do some simulations. I'm going to use, say it's send is low. And we're keeping send low. And then we want to send on 1. Okay. Data bit index. So I don't think we need to, not exactly sure what I was thinking here, but I don't think we need to put anything in the bit index here. We need to, we're in the stop bit state. Yeah, I think me writing to this was a factor of this rule I was trying to adhere to, for saying to avoid latches, which we'll talk about at some point, saying ensure all output and in-out ports are assigned a value on every cycle. I think if they're registers, then they are essentially, right? We're always assigning the wire. If we're saying output register, in-out register, then we're doing that kind of like shorthand for assigning the wire to a register. And so I think that this is no longer something like we have to be doing in that case, because essentially we are doing it, I guess. So yeah. It doesn't hurt though to have it for sure. But the data one is, we do want to assign to data only when we receive, really. So we can take a look at this and see how it goes. But essentially the data, right, is coming out of the receiver and going in. I'm wondering if like for one character this is going to work. But for instance, one of the things I noticed on the NANDLAN site is that they're saying that, for instance, at the start bit, they're only like getting to the middle of the start bit, and then they're saying, okay, we're going to move over because, so let's actually look at why that might be a good thing to do. So, this is going to be a painful use of Excalibur here, but let's say this is the signal we're getting, right? A digital signal, so ones and zeros. I'm going to have to create some Excalibur like template stuff here at some point, because this is going to be far too tedious. I really want some sort of writing utensil as well, but anyway, so let's say let's actually use the value. So start bit receive equals 0 is when we go into the start bit, right? So it goes low. So let's say here, so this would be what the clock cycle looked like, whatever. So really, let's just say that it's just like staying high for a long period of time. Okay, so it's staying high, and then all of a sudden we, on one of our samples, right, we're saying, oh, it's low, I need to transition state. Okay, so depending on where we are in this, the window that we're sampling in now needs to be consistent, I guess. So let's say we sample, like it could go low at any time. Then we're like, okay, we need to go into the data bit, the start bit. In the start bit, we're saying, okay, we're going to wait a full cycle, which I think is kind of naive here on my part. And so waiting here and keeping the state at start bit. And then we're saying, yeah, I think we can get rid of some of these sends, but anyway, it doesn't matter. Keeping the state at start bit, and then we are saying that after a full cycle, or after a full window, I guess, then we're going to sample the next one for the data bit. So let's say our window is, this big between these two. What it is saying, and let's say this is the first data bit. I believe what it's saying here is we're an idle start bit. So we sometimes sampled in the start bit, and say it's saying if halfway through our sampling cycle, or our sampling window, it's still low, then we'll stay for the full cycle. But if we actually sampled it like here, right? So let's say, we were doing the same sort of sampling pattern, and we're here and here, and then we sampled it here. If we waited a full cycle, so if we waited a full cycle, then we would be, let's say, like here. And if we're here, and we move to the data bit, we're going to potentially have a situation where, like, the thing that triggers us to move and the sample of the data bit that we take is not, we're off, I guess. Trying to think of a better way to explain this. We're basically saying that if, instead of getting here and triggering going to the next one, we're saying that we'll check here, and if this value has already changed, we're going to go on to starting sampling the data bits. And so we'll sample here, and then we'll be basically resetting our sampling window here. And then we'd be just on that for all of the data bits. Now let's see, actually. So start bit, so found the middle, it says. And so if we move over, then, okay, I see. So since we're not saying to send until we've gotten all of the data bits, really our last sample just needs to be in the right place, right? Our last sample of the data bit, because that's what ultimately our stateful register is going to be driven to. So if we have this window, what we're actually saying is, well, because I'm wondering if we set it here, even if we waited till half, when we finished and moved to the next bit, then the last thing we wrote for this data bit. So let's say, like, this is data 7 here. And if we're continually writing to data 7, so let's say data bits, doing the full clock cycle, always setting it oops. Okay, so we're not actually setting it until the very end here. So So that's interesting. So if we, let's say we sampled here, we waited for half, and then we wait a full clock cycle. Ah, I know what it is. We actually are always here. And what we're trying to do is, because we're triggered on what? What are we triggered on here? The positive edge of the clock. So as soon as that switches, so I think, yeah. Yeah, as soon as the receive goes low, then we're changing. So, okay, this is very helpful. So let's say we're just waiting. So we're not actually really sampling here. In fact, I bet that we're doing too much in our start. Yeah, so they're not even considering the clock here. And we really don't need to either. Bit index equals 7. Yeah, okay. So actually setting the send is kind of important because I think it should default to 0, but when we come back here, we do want to reset it to 0. So send on one cycle and then go. Okay. So now what we're saying is as soon as we get that receive signal, right? So as soon as that signal is driven low by the host in this case, so some data is being sent, then we are going to be here. And let's just get rid of all of this. So we're triggered right on that. This is just annoying me now. Okay, so we're triggered on that. And then what we're saying is halfway through the clock cycle, we want to go ahead and move to the data bit sample. And the last, when we do the transition from, let's say, data bit 7 to, we're kind of like being naive here and saying it's changing every time. This isn't actually reality. Necessarily. I mean, it could be. But let's say it is a different 1 or 0 each time. So what we're saying is we first sample here. I'll keep this one thick, actually. And then halfway through the clock cycle, we want to reset and go to the next thing. And the reason we want to do that is because we want to be sampling in the middle of these bits here, because the last, or we want to be transitioning, I guess, in the middle of the bits. So the last one that we write, the last time when we actually transition from 7 to 6, let's say, then we, yeah, the last one, we need to be in the right realm, right? So if this is the host sending a 1, right, for the least significant bit here, then we want to make sure that the last thing that we get for the value when we transition to then looking for the next bit is in that 1 range. And so that's why we're waiting for half a cycle and then kind of like getting on our cadence. And the subsequent ones are all in the middle of these cycles. So really what we have, let's see if I can draw anything here. This is a half cycle. And then something like this would be a full cycle. Oops, always do that. Cool. Okay, that makes a lot of sense to me. If folks have other ways to explain this, definitely feel free to speak up and say, "Hey, this doesn't make any sense," or something like that. Also, I'm checking in on the quality fairly regularly here, and it looks pretty bad. So I'm hoping that it's not quite as bad as it's showing up here. But if so, we'll come back around and fix it up. Let me check one other thing here. All right, and let's jump over. And so this is where we want to say cycles minus 1 divided by 2. I'm not actually sure if that syntax is correct. Wait, and that's actually not even what we want. We want this. All right, and then when we get to the end, we're going to say, hey, please send this. So what I was wondering is if we're literally just echoing this right back, if there's going to be, if like the host, let's say, is sending just over and over again, right? We're going to go right back into idle and then jump into the start bit. And if we do that, then the TX here is going to be, it's going to be having its value modified, or its wires are modified, right? Because we're using the same thing, or we're using the same data. So it's sending. So like, let's say we are in here and we go through, populate the data buffer, and or drive all the data wires correctly, and then say send, and UART says, all right, now I'm going to start my thing of sending back to the host. And if that's the case, then if something else gets sent and received here, then we're going to start modifying this while our UART-TX here is sending out. And that is going to cause issues, right? Because it's going to send the first whatever number of bits. Although, actually, at the baud rate, right, as long as we've already started sending, if our implementation is correct, then we should have sent the first data bit before then it gets modified. So maybe it'll be okay. It does seem like it's like shaky though. So obviously you can tell that I'm not an expert at this. This might be something that is obvious to folks. But anywho, I'm gonna probably post this one afterwards. Nice. Okay. Yeah, gonna be honest, I'm a little distracted by how bad the video quality is. Yeah, it's saying that it can only play 360p here on at least what I'm watching, which I'm not sure why that's the case. I'm gonna look this up real quick in the background. let's see. So I'm trying to do 720p, and so I can tell here that my resolution is correct, 1280 by 720. It says video bitrate range 1500 through 4000, and I'm currently at 2500. So let me see here. Let's see if I can bump that up. Let's see. Yeah, I mean, we can try to get up to like 4000, I guess. That should, in theory, help, but I don't know if it's going to send my little Dell streaming laptop here over the edge. Let's see. See if that makes any improvements here. I mean, I know like the NDI stuff is not great, but at least the video of me should be coming through okay. Let's see if we can go to let's see if we can find me. Currently saying no data. One Moss Dan. Well, there's me. And live, we're looking at ourselves here. So it doesn't look okay. We're on 720 here. This is not near as bad as for some reason it's showing up. I'm thinking that bumping the bitrate there helped quite a bit. I'm gonna see if I can go back and oh, it's really not that bad at any point along here. I mean, I'd prefer that it was better, but yeah, this is not too bad. Okay, I feel a lot better now. I know no one watching this cares to look back at that, but anywho, I think that should be improved. Okay, so we need to get into Vivado. So I'm gonna take the Arty here, show it for folks who haven't seen it, and I'm gonna plug this in and see if we can get to making this work here. What we really need to do is some simulation after we get this up. But I'm just going to see if we have anything just like blatantly wrong already. I watched some like streaming folks this weekend. It seems like one of the top ones right now is the Primeagon, I think is how you say it. And they have a pretty good stream, and then they make videos and that sort of thing. I don't know if I have quite the charisma that they have, so we'll see. But was trying to get a little bit of inspiration, you might say, I guess. All right. So we're opening up Vivado. If folks were not around last time, also it looks like it's a little sad. I believe that I'm going to need to add some new sources here. UART RX. Also, I can tell my Dell here is getting a little bit stressed with the amount of with the bit rate that we added. So we'll see if this persists. But okay, so top works, and it's like I don't know where this RX is that you speak of. So we want to add a source here. Design sources, add files, RTL. This is the one that we want. Okay. And let's see if that works for us. Updating. All right, looks good. Obviously, I could just not use VS Code here. But anyway. Also, thank you, Caleb, for the positive reinforcement. That actually means quite a lot. Okay, so we've already got some errors here. Receive is not declared. So it's because I have it called in, which is arguably yeah, let's call it in. That matches the declaration by the constraints file we have. All right. Let's just see how. Let's save that. Let's just see how this looks. See if anything gets upset when we run synthesis. Cool. Also, I was thinking about opening an issue describing this. Let's do that on MOSComp. And really, I guess we are doing like the echo thing, but really, primarily what we're doing is well, we can just repurpose this one. Let's see. Implemented in 9. Let's make some references to this one. Synthesis failed. Nice. Okay. Well, we can actually look and see what the message is. TX data is not declared. Cool. So that's something we can definitely fix here. I was going to make a note. Data transmission fixed up in however still sending hard-coded data. Next step is echoing data back to the host. Ooh, my typing is atrocious today. That was very bad. All right, we're gonna see if that tightens up. Too much Excalibur, I guess. Okay, TX data is what it doesn't like. Nice, and it gives line number. Vivado is not the worst thing that's ever happened. I think I just call it data now, right? Yeah. Which is arguably less descriptive, so we'll see. Okay, I don't see any more errors right off the top of there. Also, I know a lot of folks that use Vivado really script a lot of it. At least I believe so. I'm not quite there yet, so we'll see how it goes. Also, maybe we just need to go on to moving to the open source toolchain. But I do think that a lot of folks also it's running synth design up here in the right hand corner. I do think a lot of folks use Vivado, and so part of me from like an educational perspective feels like that it's really nice to use Vivado because it's like, oh, okay, like you're going to be forced to use this thing in some jobs. Let's make it let's produce some information around it. Whereas I have a lot more confidence in all those open source FPGA folks and documenting their stuff better. So it's a double-edged sword there. Wow, this synthesis is taking a long time. But it is done. And let's just go ahead and run implementation. And we can take a look at our block diagram here. I think that's the correct term. If not, let's note that down. Docs, learn, terms. What do we have here? Instruction level, parallelism. Well, this should be its own line here. Huh. Static multiple issue. Nice. Okay. Open implemented design. So we should see more stuff on our visualization here. Geez, it is really running slow. I do have more open on my computer this time, so could be it. So I should be using, I forgot about this. I should be using asserted and deasserted a lot of times when we're talking about driving high or low for consistency. Oh, we should talk about structural and behavioral modeling as well. Okay, so we do have more in here than we had last time. Which makes sense. URTX bit index. Index 8. 3, 4. Okay, so I think this is literally our yeah, so this is this is like the register, right? It's a lookup table that we're saying is storing the bit index, I think 5 here. Or are we saying the data bit index 8? Anyway, it is a storage mechanism here. Let's see what else, if we can dive into this. Clock count, register 3. I love looking at these diagrams. They're so cool. All right. Let's generate the bit stream and see what happens though. And then we need to go back and write some simulation. I mean, like we should write the simulation first because this is obviously not like a clean workflow here. it's just a long development cycle. That being said, I do want to try to get to this on the stream, and if we get it right the first time, that'll be cool. Caleb says, never use Vivado. Does it compile export faster than Quartus? I I don't know. Is Quartus the Intel one? Also, I might be mispronouncing that. Yeah. I don't know. I've never used Quartus before. Quartus, maybe it would be correct. So I'm not actually sure. But that would be fun to test that out if I can get a dev board. Auto connect. Nice. Okay, so it found. And write bitstream complete. Okay, so the question here is, let's see if we can. Okay, so this is what we're looking for here. Once again, we did this yesterday, but this is the UART FIFO here. So the docs serial. This is what we've been using, screen. Let's see. Cool. Okay, so we wouldn't expect anything to be coming through, but in theory, if we typed something might happen. Also interesting that an A. I don't actually know how to do this, so let's just look at sending data using screen. Control J. All right, we'll try this and then we'll actually look up a more robust solution here. I don't think that's doing anything. One thing we could do is like light something up if so for instance, we have some like LEDs and things like that we could drive high. Okay, we want to exit and not open this up. Oh, actually, Caleb said that's something that pisses them off about Quartus. Okay, so it sounds like Quartus is not better. Got it. Makes sense. Okay, also, I don't know if we actually need to declare these. We'll check that in a second. I should know that, but okay. Let's look at the tool chain here. So we do want our RX in there, so we'll need to add that. And then we had some LEDs and get ports LED 0. Switch 0. So let's pass our input. Let's say 3, 0 LED. And for the receiver, let's just pass in a notification here. Oh, this is the sender. So we'll say input notif. And we're going to do that for both, but give them different LEDs. Okay, so we'll give notif LED 0. Let me make sure the syntax here makes sense. Yeah, switch 1, switch 0. Okay, that makes sense. And then we'll say notif LED 1. And or those should be outputs, maybe. Let me check that. Already A7 LED example. General IO demo. Submodules used hardware. Oh, here we go. Source HDL. Oh, these are okay, yeah. Oh, they actually have a UART transaction control. Guess we could have looked at this. That's okay. It's easier to do it, or it's more educational to do it ourselves. Okay, yeah. So these are outputs. Well, I don't know VHDL super well, so. Component, entity. Do they have any of these in Verilog? Oops. Ah, Project F is awesome. Yeah, output. Okay, cool. This is using System Verilog, but that should work for us. And that makes sense, right? Where makes sense for it to be output here. Oops. We're driving the LEDs. And they are stateless, right? They're wires. And let's see. Okay. So let's say that we want, for when we're sending, we want to make, or no, when we're idle, notif really this should be an out error. Oh no, it's input. Okay. I guess we'll make it a register as well. Which means I'll need to update that note. But essentially it's saying, right, that we're going to assign to this in a sequential logic block. We want it high, though, for all of these. This one, same thing. Okay, let's try this. See how it goes. I think it might be upset about me removing those wires for data and input. I think we do need to declare those at the top level. Take this a minute to come up here. It would be so cool if we could get this going here. Alrighty, sources, syntax error files. Yeah, I think it's going to be mad about the, oh, it doesn't like this. And then notif. So like if I don't have wire and data, or yeah, send and data declared, How does that even, let's just see if the synthesis even works. While this is running, someone who, well, there's a few folks I just kind of like wanted to chat about that I've seen on Twitter. I think Luke Wren works at, yeah, Raspberry Pi, which is really cool, and has done some really neat stuff. Amazing bio too. Interest C Verilog Python, dislike C Verilog Python. So this is a 3-stage RISC-V processor that they have worked on, which is really cool. And then White Quark, everyone knows White Quark, who's like the leader of open source FPGA things and has created a ton of awesome stuff. And then Bruno, there we go, run implementation. Bruno has some really cool stuff around learning FPGAs. Was just tweeting about it this morning. But if you want to look at Learn FPGA, this is just an awesome resource here. FPGA, Yosys, NextPNR, and RISC-V. To be added, Artie. Maybe we could work on adding Artie for this tutorial. That would be a pretty cool thing to contribute. Whoa, this is long. This is awesome. Jeez. Yeah, Bruno is so cool. Really awesome work on this. Running place design. Cool. So I'm not really sure why it says 360p on my stream, but anyway, doesn't really matter. It looked like it was coming through at 720 when we went to it directly. Reading and processing constraints. All right, so I just decided to put them here instead this time. Implementation complete. Generate bit stream. Writing bitstream usually does not take this long. While this is going, let's jump over and talk about like roadmap for this project. done. Auto connect. Yeah, one of the things I mentioned on Twitter is I'd really like to author our own tool for programming the FPGA. Basically, like doing the programming using the UART or using the JTAG circuitry. I think that would be really, really cool. Okay, so it says Bitstream was written successfully. So we're going to pull this up again and go into, what do we say, screen. I'm looking to see if our LEDs light up at all. Oh. LED 4 and LED 5 do seem to blink when I press buttons. Interesting that nothing is coming through. But when I press the buttons, there's definitely things happening. So data does appear to be coming through, which is cool. I'm a little confused why LED 4, 5, 9, and 10 appear to be lighting up. Maybe actually I could show this a little bit. So I'll move back over to my main screen. Let's see if we can get this to focus. Come on. It is really struggling. Okay. So you might be able to see it. You see those flashing there? So we are getting the LEDs to light up. And that's just each time I press any key on the keyboard, it appears to be lighting up. So I don't know exactly what's going on here, but we can definitely continue to work on it. Let's see. We'll just stay in here. So let's try it again with, I'm pretty sure we do need to have the wire 70 data, although, because like how else does it know? I'm just like passing random things here. So I also want to know about the LEDs though. So LED 0 and LED 1 seem to be, let's see, wire send. Let's open up our constraints file here. You're a little smaller. RGB LEDs. So, okay, it makes sense that 4 and 5 would light up. I wasn't even aware of 9 and 10 here. So, that's interesting. Let's see if we can just search for it. What are these named? LED 9. So not found. Let's look at the reference manual and see if those are defined anywhere. So we have our LEDs. The 9 and 10 up here just appear to be kind of user RGB LEDs. Kind of just hanging out. I don't really know what that could just be. Let's just see if 9 is in here. Oh wait, that was it. I think. What was it? LD9? Okay. Traffic flowing through the port. The transmit, LED, and receive. Okay. They're both transmitting and receiving. Huh. So I'm wondering if it's transmitting too. I don't understand exactly how like these are getting wired up, but the fact that they are makes me feel like the fact that it's transmitting hardware, where are the sources? Oh man. View sources. There we go. So 9 and 10 makes sense. Honestly, we don't really need the LEDs if that's the case, or the LEDs we added. But I'm wondering if send is let's try and run synthesis again. So one of the things I was looking up was maybe we could look at the Learn FPGA basic. RD blink. Yeah, bring in all the LEDs here. Oh man, I forgot to switch back. Sorry about that, folks. All I did was over here declare these two before they go into send. And I think they'll default to 0. But yeah, I'm not sure because like really we're passing those in and they should be driven by the URX here. Um, okay, so let's look up and see if screen is the best way to send. Let's go ahead and generate the bit stream. All right, let's program the device. Okay, it looks like that was successful. Um, so I don't think I have Minicom. Let's see. Whoa. All right, let's close out some of this stuff. I wouldn't guess that that would be causing issues, but let's try Minicom. Minicom guide. Minicom dash D. Baud rate 9600. Let's see. So not seeing anything here. But I think I'm probably not using this correctly yet. Also, I want to add this to our serial docs here. Minicom dash D dev TTY USB 1 B 9600. Oh. Control A Z. Well, this is actually very helpful. Local echo on off. Not getting anything, it doesn't seem like. Let's see. Minicom doesn't appear offline. Let's what is going on here? I think that I might have made things upset. It's like a stuck in Vim situation here. Exit. Exit Minicom. Alt Q. Oh. Huh. Seems like I just didn't really like that. Let's see if this sends. Yeah, so I am sending. That makes the LEDs light up again. So I feel like we just need to get Minicom working here. Baud rate. Let's see if there's just anything with Minicom RDA7. Sci-Fi Forum. Is there actually anything about Minicom? That does not seem helpful. What does -8 mean? I'm guessing it has to do with the bit size. Let's try. Quit. Yes. Okay. I do like the echo mode. Hello. World. Nothing's happening. What does Minicom offline mean? Seems like it just takes us a minute to come back. Man, Minicom. Why does it not like that? Install Minicom. Serial port setup. Minicom S. Eight, potentially. Minicom. What were they using? Oh, Minicom dash setup. I don't know why they need sudo for that. Serial port setup. A. TTY USB 1. And E. We want C. Hardware flow control. I have no idea. Screen and keyboard. Minicom RD, maybe. Minicom MOS, let's say. MOS. Okay, yeah. It wants, that's why we need the sudo access. A TTY USB 1. And then E, we want to set baud rate to 9600. Okay, and then save setup as MOS. Configuration saved. Okay, exit. And still not getting anything. But I don't know if it's due to the fact that, you know, we're not sending anything, or, well, actually, it would show if we were, I do like the echo. I would like to keep that on. Yeah, Minicom is not sending though. Okay, so maybe we need to turn off that. If this works, I definitely want to put a blog post out here, because this is not enough information on this, in my opinion. Which maybe I should be more comfortable with less, but come on. Why does it hold the window like this for so long? There we go. Specify, I think, Minicom sudo minicom MOS-S. Okay, so that looks good. The hardware flow control is the one we wanted. All right, come on. Okay, it's working. That is so awesome. Yeah, let me see if I can get it up here. I don't think that it's going to focus super well, but you can see the lights flashing. We're unfortunately not getting anything back, but we are sending. And apparently, yeah, we're apparently receiving too, but okay, so I'm wondering, let's try if we do screen on the other. Screen. Like maybe Minicom just isn't receiving correctly. So I guess let's give it a try. Oh, it doesn't appear to like that. Control A, Z. Oh, awesome. Caleb still seems to be around. Feel free to ping on Twitter or wherever else, Caleb. Thanks for stopping by. Definitely appreciate it. So something appears to be coming through here. Let me actually. I should just do split window here, but whatever. We'll just keep this on top for now. Okay, so this guy seems to be sad now. Let's just get rid of that one. Oh wait, this is also under my... Whoops. All right. I hate how when you make it bigger, it also increases the window size. That is highly annoying. Okay. Always on top. And let's do... Screen is terminating. Okay. Well, let's see if we can help it. Screen is terminating. Let's see. Ask Ubuntu. It doesn't seem like... Here we go. This looks... This is dangerous, but no process found, yeah. Okay. Screen is terminating. Well, there is no screen from what I can tell. Yeah, so it seems like it might be a permission issue. Let's see. Minicom. So I'm gonna close this for now. Let's just see if we can bring this back. $9,600. Okay, so that's working. Strange. Okay, let's make this one always on top. New window. Moss comp. Moss. Minicom. Which got a lot darker in here, I realized. I need my light to be less dependent on the whatever's outside, whatever's happening outside in this room. I can fix that in just a second. Minicom, and we wanted to say Moss. Okay, so yeah, we can't be connected to both, I guess. So that's why screen was failing for us. Line wrap. Wow, I like Minicom kind of a lot, actually. Okay. So I'm wondering if it's just not able to print things, and we could try that out by bringing back some of the printing the hard-coded string. I really don't want to go through doing that again necessarily, but So we'll save this stuff. Okay. So we could try to where did we put this? I thought we put it in there. Espen. I think it's in. All right. It wouldn't be in there. I don't know why I'm looking. Let me just grab this from. Tools. That would have been smart. I really just need to add that to my path, which may be obvious to folks, but alas. So what I want to do is try sending the welcome to Moss Computer thing. Welcome to the Moss Computer. And see if that comes through on Minicom to see if that's our issue or not. This is where scripting would be awesome, right? Because I wouldn't have to pull this open and do it again. Let's just make sure this looks good. Yep. As expected. Cool. So it'll take a minute to come up. Also, I'd mentioned that I kind of want to look at Rust, writing a JTAG programmer in Rust. I was going to see if there's any. JTAG abstraction library. This looks kind of old. This is probably, yeah, so this is like the tap thing here, the tap state machine. I was thinking of calling the tool mtap. Rust on ESP. So probe RS is, oh, okay, so maybe probe RS will support this for us. It's built-in USB JTAG serial. Yeah, so probe RS is definitely a really cool project. Run implementation. I believe it's from Ferris Systems. Maybe I might have that wrong. Let me. Flash program. Read and write arbitrary memory of the target. Yeah, this is a really cool project. This is probably actually going to do what we need here. I think this used to live somewhere else, maybe. But, yeah, anyway. Also might write it from scratch just for the learning, right? Looks like it's doing routing now. All right, generate bitstream. We have to connect to the hardware manager again. And then I might go eat here in a little bit because I'm kind of hungry. So yeah, I do have this light here that I moved to kind of be behind the desk. But it's obviously not like a super large light. So I'll try to work on the lighting for the next stream. Oh yeah, Caleb was just saying, looking into some Haskell for working with dev boards, but the ESP Rust seems very cool. Yeah, I think they are doing some of the coolest work around this right now. I saw a little bit of stuff with Zig, which I haven't gotten into Zig too much. Definitely, definitely interested in Zig. Part of me, I know there's trade-offs between like Rust and Zig, and they're kind of they have subtly different goals. But part of me is just feels like that I like the style of writing Rust, and so makes me lean towards it over Zig. But I'm also just like interested in Zig in general, I guess, regardless of if it's the what I practically want to use for most projects. So what I want to see here is we're connected, and I want to see if just flipping the switch and sending welcome to the Moss computer works. So here goes. It doesn't. Okay, so that's actually kind of encouraging in a way. I know that's a little confusing, but it means Minicom isn't able to read from this. Well, in theory, actually, before we say that, absolutely, let's do. And I'll try it here. Oh, it's not coming through on screen either. Let me make sure I'm using the correct switches. Yeah, that is very interesting. Let's try and flash the bitstream again. Maybe I didn't get that quite right. JTAG device index 0. Okay. Okay, so that's working, etc. And I'm going to try the... Oh, okay, so it is printing. And I can see that it's also receiving by the LED flashing, but it's clearly not able to echo it back. Reneri says, look like time to pull up the logic analyzer. Well, I think we've got the issue diagnosed now. I know it's on a bit of a delay. But I want to get a logic analyzer. I don't have one. I want to get a oscilloscope. I said that weird the first time. But they're pretty pricey, so we'll see. Although I have made kind of a commitment to working on this, so might be easier to justify now. Also, thanks again for stopping by, Verneri. Let's see. So it seems like it's just not handling the input very well. But trying to think how to best address this. Verneri says, by the way, at least screen by default doesn't print sent text to standard out. Yeah. So if you're seeing what you're typing, that means your loopback works. Yeah. The Minicom, I had the echo back to standard out on. And so, yeah, I am able to see sending for Minicom. I don't think I realized before that that there was an indicator here. Yeah, so screen I can see by the LED flashing that it is receiving inputs. So that's good in a way. But we're just not handling them correctly on the in the module that we wrote. So I am going to let's go back to our other code. Let's see how it actually handles this. Source. Can we get a refresh here? Maybe. Should be able to source this from the constraints. Refresh hierarchy. I'm pretty sure we added this to the, let's see. Boards XC7 XPR. Yeah, we definitely have this present, so I don't know why it's not working here. Seems like Vivado doesn't handle this very well. URTX. I don't want to bring this in again because it's already here. Refresh. I'm just going to restart it. Have it pick it up correctly. Exiting Vivado. Get our nice long startup again. let's see. Yeah, so there it gets it okay. So I was wondering, one thing we could try to do is say that like we'll just send a like W or something like that always. Um, Even if that's not at all what it should be. So TX data. So basically, we're just not going to consider what the actual data is and say reg 70 tx data, and we'll just say equals w. And everywhere where we're saying data, we'll just use tx data instead. So basically, when we say send, we go to start bit. We pull out down for 1. Oh, this is interesting. Because it seems like the send is being received correctly. The data does not seem to be. Also, let me quickly open up the window so there's a little more light in here. All right, maybe too much light in here now, but that's okay. Oh, nice. Verneri says they have 2 suggestions that could help with debugging. I'm guessing one of them is actually doing simulation so that we don't have to go through all of it, which I'm being a little lazy on right now. Bit index. Verilator. Yeah, set up a simulation test bench. Yeah, so Verneri's two suggestions are, use pass it through the Verilator lint only, and then write a test bench. Which test bench is definitely the way we need to go. I'm gonna give this one more shot, just because I think I'm gonna sign off here fairly soon, and I'm basically gambling. You could say. Which is never a good way to develop. But yeah, we do need to write a test bench here. In fact, while that's going, maybe I'll actually go ahead and get started on that. And we can do some pretty neat stuff, such as like generate the waveform and stuff like that. Yeah. So this is not the one we have pushed up here. But we're basically flipping the clock signal here. And so I'm not an expert at C++. This was us flipping the switch. I'm trying to remember exactly what we had here. So first thing we need to do is actually generate the new output. Oops. Note info. Oh, so Verneri's suggestion's already paying off here. Off unused. Bits of signal are not driven. 3 and 2, yeah. Warning. Signal is not used in top URTX. Yeah. Let's temporarily drop some of these. Where is our Verilator? So these are good warnings that we want, but I just want to temporarily go through. All right, cool. Also check back in on our, okay, it's doing routing. Okay, so creating an instance of the vtop, and so I guess like we haven't talked about Verilator at all. So basically what this does is it generates a C++ model that lets us write, that lets us write a test bench in C++, which is really nice. You can also do testing in Verilog itself. Like you can write test benches. In fact, actually what we were looking at earlier, if I still have it up, I don't think I do. The NANDland one had some test benches in it. So anywho, all right. Yeah, eval. So previously to make so like a good example of how we could make this better is in our, where we're setting things like the cycles, like the number of clock ticks per bit transmitted here. We're setting the baud rate. If we instead made this a parameter that could be set, it would make it a lot easier in our test benches, because instead of clicking the top, ticking the clock, sorry, you know, however many times, what was that, 10,000 something? Yeah, 10,416. We could just do, one clock tick or something like that, and then our test bench gets a lot easier. So we definitely need to invest some time and effort there. Open target. Whoops. No, I want to auto detect. Also, thank you again, Verneri, for showing up and giving input and insight. Definitely really appreciate it. All right, is programmed. So I'm going to close this for a minute. Close it in my shame of the of what we have there now. And basically, I'm going to try to, I'm going to type and see if we get a W back. So I'm not getting anything transmitted at all. I am getting things received. So I might have missed something there real quickly. Your TX, oh sorry, your TX here. Input, send. Send and then data, is that right? Send data. So that's interesting because previously it was allegedly sending things. So we have gotten Minicom set up, so I actually feel okay about the progress we made today. Which, by the way, like, you know what? When you're trying to learn stuff, feeling okay about doing nothing may have gotten you closer. So even if that was the case, which I don't think we just did nothing today, that would be okay. Receiving. Wait, so one thing that's interesting here is we're no longer getting the notification on receiving. On the RTL. Did we switch around the top? TX data. Okay, so this all looks right. Okay, so we switch those. So that also looks good, I think. Yeah, notif moved after data. So that's pretty confusing. I'm not sure it actually programmed the device. I'm going to do this again. Let's see here. Okay, now I'm getting them back. Okay, so we are getting stuff sent back. Okay, so that's actually a pretty good improvement. So it's not printing the correct thing, the correct character here. But yeah, so we are getting that W sent when we send information. And I'm guessing that we're having the same sort of situation where we're sending it backwards, which is really annoying. It has to. I think it just. I guess it has to do with the way that Verilog instantiates arrays. So let's jump over it back. Verilog character array. I've seen this one so many times. Anyone who says otherwise is wrong. So the way that I'm going to test this is to actually see what we're getting back. Is to also do this. So I'm glad that we've discovered that we can, in fact, send on it. Let's do this. Well, also, I just realized that I had. Also, now I'm not sending or receiving. Interesting. Let's try now. Nope. Huh. Interesting. I wonder if listening is messing it up. Yeah, it is. Let's see. Yeah, that breaks everything. It also just freezes this up. Interesting. Minicom Moss. All right. wait, actually, what I wanted to try here was Minicom print hex. Display hex. Huh. Let's try that. That's actually kind of cool, honestly. So it seems like whatever I type, getting EA back, which I should be able to just do off the top of my head, but why does that keep happening? Actually, let's see if we have a print binary. Minicom print binary. -H. Display. Let's try H. Or 8, sorry. That doesn't help at all. Why is everything crashing here? If we close some stuff? Weird. Whatever. Brave is having some issues, clearly. All right, so we're getting 11101010, which is apparently E with like a I don't know the proper terminology for it, but kind of like a hat. And so let's reverse that. I can show you what I'm doing. So we have EA here. This is our binary number. And so we want to say, well, let's say binary to ASCII. So let's take that and we'll say here is that symbol. But really what we want is 0, 1, 0, 1, 0, 1, 1, 1, right? And that's our W. So the way that Verilog is, the way that it's handling, or the way that it's instantiating the array is kind of backwards here. I don't know if, so I'm going to hop back over to Brave here. I don't know if that's because we instantiate with the, let's see, array size variable. I'm pretty sure you have to use the format that we're using. Like, I don't think that 0, 7 is valid. Well, maybe it is. Let's try it. And then this will be it for the day. So I'm going to I do want to take that. So the minirc dot moss. It'd probably be useful to have that in here. Also, I'm not sure if y'all can hear that car horn, but apologies if so. Let's take run implementation. Go back into VS Code. New folder, dev. I think we were using dev to mean device. No, we said boards. Okay. And let's just put it in here. This is what we want. minirc moss. Okay. So Reneri says you can choose the Indianness. Okay. Well, that is super helpful. If I had just done that on the stream yesterday, well, no, that was a while back. We were showing on the other stream that I had previously put them in backwards. But yeah, nice. Thank you. I feel pretty dumb for doing that, but you know what? There is no such thing as that here. We're just learning stuff. All right, we're writing the bit stream. And then I'll just add a to do. Oh, it's taking longer to write the bit stream than I thought. There we go. Right, bitstream. Nice. Okay. Programming worked the first time, but all right. And then we're gonna try this out. And when I type, we should get back that capital W. And then we might round that up for today. And we might open like a draft PR and say, hey, we need to replace this. All right, so I'll type some stuff. Nice. Every time I type, it appears I'm getting. Nope, then it gets hung up. Interesting. It is receiving, but it stops sending. Interesting. Well, let's see if I reset. Oh, there's some stuff. Interesting. All right. Well, the moral of the story is that we need to write some test benches so that we can do some better debugging here. Okay, so while I'm typing A's, I reprogrammed it. I guess you could see that. It works. So it appears to work with any character here, except for if I type like really fast. No, actually that appears to keep working. I don't know what the problem was last time. I think it's still printing, it's just not wrapping. Where is word wrap? Line wrap. W. Yeah. Okay, it does eventually get hung up, it seems like. Interesting. I'm guessing that has something to do with timing. But I think that's going to wrap us up for today. I feel like that was kind of, or fairly productive. Let's go ahead and exit. I'll add the mini RC up here. What are we on here? Understanding JTAG. Okay, I'm going to close Vivado, and I think we should get this working before I push it up, but we can at least get some draft stuff up here for folks to be able to see what we worked on. Docs, dev, serial. system and the host machine. There are a variety of utilities that can be used to connect over serial port. Screen. XXD is just, you know, reading directly from it. Anyway, let's see, we were going to push some stuff up. So we'll say do assert send after data is set. Oh, and our Verilate is going to fail. So let's see if I can correct some of those warnings. Alrighty. Signal is not used. Yep. Oh no. That is not what I meant to do there. There we go. Close call. Okay, so I am going to add some no-lint directives here. Little bit Indian vector. Most significant bit is less than least significant bit. That appears not to be... Okay, so I think this is what was actually confusing me before. Because I got this warning. Verilator. I don't know what a packed. Do some research on that. Does it actually? Yeah, I don't even know exactly what that means. Little bit Indian vector. Most significant bit is less than the least significant bit of bit range. So I guess it just doesn't like. So maybe it's convention to Verilator. Little Indian versus big. And I don't know if it's just saying like this is a little Indian vector. Okay. What is the little lit Indian? Yeah, so it seems like it's just not convention, which is interesting. We can actually drop the switches though. And we'll just do 0, 1 here. And in top. Oh, that's fine. It's not going to get all the way there. Okay, so it simulates somewhat correctly. it to also for the switches here. Whoops. We're not using the buttons, and we're only using these two, or the first two, rather. And honestly, we don't really need the LEDs because we already have the LEDs saying that we're transmitting. I mean, like the notification might be nice though, and also it'll serve an example. So let's stick with oops. What do I have? What is that? Oh, that's icy. Let's do the other first. So we're updates the UART transmission module to send data on wires when send is asserted. Temporarily hard code sending the W character as echoing the wires is not currently functioning properly. It's like very weird terminology. I need to like still develop some language around like sending the wires doesn't make any sense. So I need to do some work on that for sure. But at the same time, like maybe it'll make sense to some folks. So like bridging that gap of terminology, I think should be a goal here. What is the XPR file? I guess too. Vivado sources. Alrighty. And then we were gonna add the serial docs, I think we said. Flow control. I was going to see if there's an option to turn off hardware flow control. See if we have a good definition of a serial port. This looks like a... Nice. We might add this in a bit. That's cool. Just some information about serial ports, and I think some historical stuff about RS-232. We'll keep this as is. All right, and then I'm going to pull this up on Chrome here so that I can make the pull request, and we'll do a draft, but number 8. Fixes number 8 eventually. And we'll make it a draft. Nice. Alrighty. Well, I think that's going to wrap us up for today. I know that was a pretty long one. Definitely appreciate folks stopping by as usual. If you have any feedback or anything like that, ways you think that the stream could be more useful and would be a better use of everyone's time, definitely feel free to reach out. Twitter, GitHub, wherever. And yeah, we're going to keep kind of like defining the direction for this project. I know a lot of it seems kind of like rudimentary and maybe I'm not the best guide or the most experienced guide, we should say. But I think me bumping into some things is going to be helpful. And then my goal is to take some of these streams and turn them into actual content that folks can consume, right? Really, one of the motivations for having this stream is just one, it's like a focus kind of like forcing thing for me. And 2, it allows folks to see that I'm very human and can bump into issues and, run into a wall. 3, it brings awesome community folks like Caleb and Verneri here to provide input and feedback and help me get unstuck, help everyone get unstuck. And then 4, it can serve as that motivation for being able to produce like more digestible content that's more useful. So anyway, that's kind of the goal here. But yeah, thanks again, everyone, for coming out. And if you're watching this later, feel free to drop comments about what I can